Hello, I'm Seema and welcome to part 29 of the chapter Organic Chemistry, Some Basic Principles and Techniques. In the past few videos, we have been doing the electron displacement effects on covalent bonds, and the different effects that we've studied are inductive effect, resonance effect and electromeric effect. We are still left with the fourth effect, that is hyperconjugation, which we will be doing in the next video. But right now, before we move on to hyperconjugation, it is important that we be clear about the effects that we have already studied. In the case of resonance, I told you that resonance occurs in molecules where there's a conjugation of bonds. That is, where there's an alternate single and double bond and the electrons are totally delocalized. They kind of dance around in the molecule. Therefore, resonance is a little easy to understand. The other two effects, that is inductive effect and electromeric effect, you might get confused in these two. Therefore, it is important right now to understand them, to kind of tabulate them and see their differences, so that once you know their differences, remembering them individually becomes easier. And that is the reason why I'm doing this special video here, to differentiate between inductive effect and electromeric effect. So let us start with it. If you want to understand these individually in depth, I would encourage you to watch the videos that we have done on these, titled Inductive Effect and Electromeric Effect. But as we do the differences, it will become clearer to you. Each one will become clearer to you. Inductive effect is a permanent effect, right? These are the differences. It's a permanent effect, and electromeric effect is a temporary effect. I told you that whenever the substituent which is causing the electrons to move, since we are talking of electron displacement, electrons being moved from their position, this occurs due to a group or an atom which is present somewhere in the reaction mixture. If the group or atom is present inside the molecule itself, then it causes a displacement which is permanent. Why? Because this atom or group is present in the molecule permanently, and since it is present permanently, its effect will be seen permanently. On the other hand, if the displacement or the movement of electrons is taking place due to a group or a substituent which is present outside the molecule, then that effect will be seen only for that much time that the external source is present. Once the external source leaves, the effect also vanishes. So what do you understand from this first difference? That inductive effect is a permanent effect and electromeric effect is a temporary effect. It means that inductive effect is due to the presence of a species, an atom or a group within the molecule, the substrate. And on the other hand, the electromeric effect is due to the atom or substrate which is outside the molecule, which is not the substrate. So in an organic reaction, what do we have? We have the substrate and we have the attacking reagent. So if it is not in the substrate, then automatically it is in the attacking reagent. Right? So we say electromeric effect is a temporary effect because the cause of that effect is not in the substrate, in the molecule itself. The cause is external, so it is present, and the cause is in the attacking agent or the attacking reagent. That is the first difference. Both inductive effect and electromeric effect are plus and minus. Inductive effect is represented by I, the alphabet I, and electromeric effect is represented by the alphabet E. And in both of these we see plus I, minus I effect, plus E and minus E effects. The plus and minus is not for the charges. The plus and minus is talking about the electron density. Since we are talking of electron displacement, plus means where the concentration of electrons increases in the carbon chain or the carbon of focus. And minus would mean movement of electrons away from it, right? So based on that, let us understand inductive effect first, and then we'll go to electromeric effect, and then I'll take the rest of the differences. Inductive effect is due to an atom which is present within the molecule. Now this atom can be a little more electronegative atom or group, could be having an atom or a group which has more negativity than the carbon attached to it, or it may have less electronegativity in comparison to the atom that is attached to it. In this case, chlorine is more electronegative than carbon. As a result of which, what happens, whenever two atoms which are bound by a covalent bond have different electronegativities, the atom which has more electronegativity has a tendency to pull the shared pair of electrons towards itself. So that is what chlorine does. It pulls the shared pair of electrons towards itself, thereby making chlorine partially negatively charged. Why do we say partially? Because there is not a complete transfer of electrons. The electrons have only slightly shifted towards chlorine. The bond is where it is, only it is kind of partial towards chlorine. As a result of this movement of electrons, slight shift, the carbon becomes partially positively charged. Now, since this is partially positively charged and this is neutral, it has an effect on these electrons. These electrons tend to help by removing that positive charge. And how do they do that? By shifting a little towards this carbon. And when they do that, the inductive effect, this is called inductive effect, the effect of movement of electrons, but it moves to the next carbon, and you see that it has been transmitted to the next bond. Now, as a result of this carbon becomes delta positive. It also acquires a positive charge which is lesser than the positive charge of this one. And the next carbon, if there was another one, now it would affect the next bond and pull those electrons towards itself. But what happens as the positive charge here is due to the electronegativity difference, but the electronegativity difference between these two is not as great as the electronegativity difference between chlorine and carbon. So this effect will be diminished, it will be lesser. And the next one, which is already lesser, positive, delta means part of part, partial of partial. So it is even more or even lesser positively charged. So the difference between this and the next carbon would be even lesser. And therefore, although that will also pull electrons towards itself, but the effect gets lesser. The positive charge gets lesser and lesser over the chain. But what is important in inductive effect for you to remember is that the effect is not localized. It is moving in the chain. And here you may confuse this with resonance, because in resonance you find electrons which are, the delocalization occurs throughout in a conjugated system. But the difference here is that here the electrons are only slightly shifting, but in resonance they dance around the entire molecule. They kind of get delocalized, they totally move around. But here there is no freedom, they are just shifting slightly. So the positive charge, it keeps getting diminished, and therefore, since this positive charge has been induced by the presence of an electronegative atom here, it is known as inductive effect. Why is it minus I effect? Because the negative charge has moved away from the carbon chain. Since it has moved away from the carbon chain, we say it is decreasing, the electron density is decreasing in the chain, and therefore it is positive charge which is being induced. On the other hand, in plus I effect, what do we see? That methyl group is now chlorine was an electron withdrawing group, it was pulling electrons towards itself. Methyl group is an electron donating group, it pushes electrons away from itself, although both of them are carbon. But the methyl group has a tendency to push electrons. Since it pushes electrons in the carbon chain, negative charge increases. This carbon gets negatively charged and this carbon becomes positively charged. And as a result of this, what happens? Since this becomes negatively charged, now this in comparison to this is positively charged. So it starts attracting those electrons. The electrons, this CH2 group pushes the electrons towards the next CH2 group, which then further pushes the electrons, but the effect again starts getting diminished, more and more diminished. And as you move along the chain, but this time it is negative charge, the electron density has increased in the chain. Therefore we call it plus I effect. right? So what is inductive effect due to? Inductive effect is due to the electronegativity difference between the atoms which are bound, right? On the other hand, now let us come to electromeric effect. What is electromeric effect due to? I told you, first of all, it's a temporary effect, which means it depends on the attacking reagent. So it depends on the nature of the attacking reagent. Now the same thing is happening, displacement of electrons is occurring. If the attacking reagent, it comes and attaches itself to one of the atoms of the carbon chain of the substrate. So if the attacking reagent is negative, right? If the attacking reagent is negative, the electrons, now there is one difference here. Here we saw the electrons were of the sigma bond, but in electromeric effect, the electrons that move are not of the sigma bond. It's not a shift, it's a complete transfer of electrons. And it's a complete transfer, and if that attacking group is negative, then the electrons will move towards that carbon of the pi bond, not of the sigma bond, of the second bond, will move towards that carbon to which the substrate will, to which the attacking reagent will attach itself. Because the attacking reagent is positive in charge. If the attacking reagent is positive in charge, then the electrons will move towards it. But if the attacking reagent is negative in charge, the electrons will move away to the other carbon atom. You know, I'm not going to tell you this in details in this video. Why? Because I have already explained this in the previous video. So I would encourage you to watch that video and then come to this, and then these points will become really clear and easy for you, because this would just be a revision there. So now take a look here. In the case of electromeric effect, it is the second bond or the third bond which breaks, and there's a complete transfer of electrons. The attacking reagent, it is positively charged, H positive. It comes and attaches itself to this carbon. So naturally these electrons, where will they go? They will go towards the positive charge. So since hydrogen was positively charged, these two electrons will move to this carbon, and you will see that since they move to this carbon, the hydrogen gets that extra electron of this carbon, becomes neutral. But this carbon, the other carbon, due to the loss of electron, becomes positively charged. So the species that you get is an ion. As a product of electromeric effect, what you get is an ion. It's a positively charged ion, because there was a complete transfer of electrons. In inductive effect, you do not get ions. You only see a polarity in the molecule, a slight polarity, but it is not a proper charged particle. If the attacking reagent is negative, on the other hand, it comes and attaches itself to one carbon, then the electrons of the second bond, they will not move towards the negative charge. They'll move away from the negative charge, naturally, because they will experience repulsion. So the electrons will move to this carbon, and this carbon in the pi bond, one electron belongs to this carbon itself, but the other electron belongs to this carbon. Therefore, when both the electrons come to this carbon, the carbon becomes negatively charged, and the Cn negative, which was negatively charged, it used its electron to form a bond with carbon. Therefore, it got neutralized, and the species that you got was a negatively charged species. So how do we explain? In this case, we said plus I and minus I was talking about electron density increasing and decreasing. Here also, indirectly, we are talking about electron density increasing and decreasing. This is plus E. This is in terms of the carbon to which the attacking reagent attaches itself. If the electron density is increasing on that carbon, then it is plus E effect. But if the electron density is decreasing on the carbon to which the attacking reagent attaches itself, then it is minus E effect. So this difference is also clear to you. Now let us come to reading the differences, and one more point here. Minus I effect is shown by all those groups which are electron withdrawing, and examples of electron withdrawing groups are NO2, CN, COOH, COR, OAR, or OC6H5. These are all examples of electron withdrawing groups. And plus I effect will be shown by electron donating groups. So you'll have methyl group, ethyl group, tertiary methyl, secondary butyl, or whatever, secondary or tertiary methyl. Any of these alkyl groups or substituents of alkyl groups, they will all be electron donating groups. So that was an example of what kind of groups would show these effects. And in the case of electromeric effect, all species that will be positive would show plus E effect, and all species that will be negative will show minus E effect. So let us now read out the differences. This is a permanent effect, this is a temporary effect. You understood. Permanent due to the cause being inside the molecule, and temporary because the cause is outside the molecule. This effect is due to the electronegativity difference of a substituent in the molecule. The electronegativity difference between the carbon and the substituent in the molecule. So the cause here is electronegativity difference, which is causing polarity in the molecule. And due to electronegativity difference, one of the atoms, the more electronegative atom, is going to pull electrons towards itself. On the other hand, what is the cause here? The cause of the shift of electrons, it is the nature of the attacking reagent. If the attacking reagent is positive, then the electrons are going to move towards it. But if it is negative, the electrons are going to move away from it. So here it is due to, the effect is due to the nature of the attacking reagent, whether it is pushing electrons, or is it electron withdrawing, or is it electron donating. In this case, there is only a shifting of electrons that take place. In inductive effect, there is not a transfer of electrons. There is only a shifting, a slight shift of electrons. While in electromeric effect, there is a complete transfer. Electrons, the pi electrons, there is a transfer of electrons leading to ion formation. Did you see? You had a positive ion here and a negative ion here. So cation and ion. The ions are formed as a result of a complete transfer of electrons. In this case, it is the sigma electrons which are just shifting, but here it is pi electrons. It is essential that this effect only takes place in those molecules where multiple bonds are present. This effect will not be seen where you have single bonds, because it is the pi electrons which are moving. So only those molecules which have multiple bonds, double bonds or triple bonds, will show this kind of an effect. On the other hand, this one is going to show, it is seen in saturated compounds also. It may be seen in compounds with multiple bonds also. It's not necessary that you have only one effect being portrayed or being shown or displayed by the molecules. Sometimes in the same chemical reaction, you will see that the substrate may show another effect, may show more than one effect. So it is usually seen in saturated compounds also, and it can be shown by compounds which are unsaturated too. Now the effect is carried over in the chain, that is, it is transmitted through the chain. You notice this, that whatever the effect you see on the first bond, you see it till the fourth bond. After the fourth bond, it becomes so weak, the effect, because with every step the effect gets diminished, it gets lesser and lesser and lesser. After the fourth bond, it is almost vanishing, it vanishes. Therefore, this effect, that is inductive effect, is transmitted through the chain, while electromeric effect is a complete transfer of electrons. It is not transmitted through the chain. In the case of resonance, though, there is a transfer of electrons, of the pi electrons, and it is transmitted. And the reason for its transmission in the case of resonance there would be that there is alternate single and double bonds, due to which the electrons can jump along the entire chain. Here I would like to mention one more thing. How do we represent the electrons that are shifting in this case, in the case of inductive effect? We show it with the help of the single bond that is there, and we show arrows. The arrows show the shifting of electrons. For example, here you see the arrows are here, but in plus I effect, the methyl group is electron donating group, so the arrows would point towards this direction. So we make arrows on the bond itself showing the direction of the shift. But in the case of electromeric effect, there is a complete transfer of electrons, and the movement of electrons is shown by a curved arrow notation. So in this case, we use a curved arrow notation where the tail of the arrow shows you the bond from where the electrons are moving, and the head of the arrow shows where both the electrons, the atom to which both the electrons moved. So this is another difference that I could have listed here, that the transfer of electrons here is shown with the help of arrows on the sigma bond, while here the transfer of electrons is shown by the curved arrow notation. So when you are learning these effects, it is important to keep in mind, when you're studying one, keeping in mind the other ones and revising them time and again helps, because that will make each effect very clear in your mind. So I did this special video for you to help you to really learn and memorize these different effects. So with that, I'll wrap up the video. If you found it helpful, give it a thumbs up, subscribe to my channel, recommend it to your friends, and please keep returning for more videos in chemistry. Thank you for watching, and bye-bye for now.